Today's video notes are titled 11-6 Volume of Pyramids and Cones. And they're also brought to you by the 2016 Summer Olympics in Rio. At the bottom of your page, please reserve 12 lines for example 3. It's going to be kind of a big one. And the rest of the space up here, your example 1 and 2 need some substantial space, and the vocabulary reminder can be relatively small. As we're racing through our unit, get it? Racing through our unit, I wanted to take a minute to remind you of some important vocabulary. So let's move our racers out of the way, and please copy this square pyramid and this cone. We're going to take a minute to look at the difference between the height versus the slant height, otherwise known as the curly L and lowercase h. Now, both of these have the word height in it, meaning that they're a line that's perpendicular to another line, but the placement of that height is very different. The height for a pyramid goes from the very topmost point to the center of the base, making a right angle. That's the height there. The height of a cone, again, goes from the topmost point to the center, making a right angle with the base. The slant height is exactly that. It's slanted. It goes from the topmost point to one of the edges and makes a right angle, and that is the slant height. The slant height of a cone, it's kind of hard to see, but it's literally one of these sides. Now, an important thing that I'd like you to see, and this is kind of a new thing, depending on what I'm asking you for, whether I'm asking you for the surface area of the volume, there's an important relationship between the slant height and the height, the slant height and the height. I'm going to take a third color, and you might want to do that too. If I connect the bottom of the height to the bottom of the slant height, it creates a right triangle. Right there. So that's an important thing to be looking for, especially if one is given and the other is not. You can always find it using the Pythagorean theorem. Just a reminder. And now for your volume formula. You know from last video that the volume of a prism is the area of the base times the height. And from the discovery that we just did, you know that 3 pyramids or 3 cones can fit inside one cylinder. So 3 pyramids fit in the same volume of one prism, which makes sense in the formula because it would be the area of the base times the height divided by 3. Now, of everything on this page, obviously I want you to copy this grid right here, but it's worth it for you to make a connection between these two and to know why it exists. Now let's put those formulas to use. I'm asking you in example 1 to find the volume of the bricks in one of these pyramids. So these are 3 pyramids in Egypt. I'm going to go ahead and move this to the side, and here's one of those pyramids up close with all of the measurements. Go ahead and copy this down and note that I've given you a rectangle base, that I've given you a height and another height. One is the slant height and the other is the regular height. Our formula is the volume is the area of the base times the height divided by 3. And I'd like you to follow 3 basic steps. Step 1, find the area of the base. And step 2, plug in your values into the area of the base times the height divided by 3. So let's go ahead and do these calculations, and I want to warn you this is going to be a very big volume because pyramids are very large. So here we go. Starting off with step 1, I'm going to color code this guy. Step 1, I'm going to find the area of the base, which as I mentioned is a rectangle. That means I'm going to multiply the base of the rectangle times the height of the rectangle. The base times the height. That means I'll be multiplying 250 feet times 220 feet. Okay, clearly feet times feet will give me square feet, and I'm going to spare you the trouble of multiplying 250 times 220, and I'll go ahead and tell you that it's 55,000 square feet. That's a very big rectangle. Now for our last step, I'm going to use green for my second step, and I'll go ahead and put that here. So for my second step, I'm going to plug in my values, which is the area of the base, So that's 55,000 square feet. I know I'm going to divide that by 3, and I need to multiply it by the height. That's how tall my pyramid is. I remember what I said. Here we have my slant height, and here I have my actual height. That means I'll be using 290 feet. Now you've got 55,000 times 290. That's a huge value. Now let's put the numbers in, then we're going to make sense of it. I've got 1, 5, 9, 5, and 4 zeros divided by 3. When you put those commas in there, that's 15,950,000 divided by 3. Now before I plug this into my calculator and give you the actual value, what do you think it's going to be? It's approximately 15 million divided by 3. Yeah, it's going to be about 5 million. And we're not surprised by the result. It's 5,316,666.6 repeating feet cubed. Where does the feet cubed come from? I have feet squared times feet, which leads to feet cubed. That is a very large pyramid. For example 2, we're going to start with a word problem. I love ice cream, especially Rocky Road ice cream, and this is true. How much ice cream can I fit in this cone without spilling any out? So I'm saying without having any ice cream on the top, which would be ridiculous, but let's just say for some reason I only wanted to fill ice cream inside the cone. How much ice cream could I fit inside of here? So let's take a look at the actual dimensions. This is actually real. Here we go. So this cone has a height of 15 centimeters and a diameter of 6 centimeters. Let's go ahead and get ready. My volume is the area of the base times the height, but divided by 3. It's a third of that. My first step is to find, the area of the base. The area of the base is a circle, so I'm looking at the formula pi times radius squared. Now they've given me the diameter, not the radius. The radius would be half of that value, so half of 6 would be 3. So my area of my base is pi times 3 squared, or 9 pi centimeters squared. Okay. Now I'm ready to plug into my formula. Volume is the area of the base times how tall your cone is. The area of my base is 9 pi centimeters squared, and my cone is 15 centimeters tall. I'm going to take that value and divide by 3. Now my volume, what I'm going to do here is I'm going to multiply 9 times 15, which is 135 pi, and then centimeters squared times centimeters to the first is centimeters cubed divided by 3. Now these two numbers can be simplified, so my volume is 45 pi centimeters cubed.